This video is going to continue the discussion of absolute value equations and inequalities, and then we'll be moving on to other topics. But I want to show you kind of where we've been and where we're going, because I want you to learn how to study for math as well as just learn this math. So what the idea is, you develop a general list of steps. Nothing really too specific, but just general guide points. And then you use that list as much as you can. Now, you may add a line or two, or you may add in notes saying, don't forget to do this, little stars for things that you keep forgetting. But on the whole, the main body of the list lasts as long as possible for any kind of problem that's similar to that, all right? So if you look in the top left corner, we started off solving just plain old linear equations. Simplify the left-hand side, simplify the right-hand side, isolate your variables on one side, isolate all your other numbers and constants on the other side, divide, multiply usually to get just what one of the x's is, right? And then you should always check your answers, but that's not in there. If you keep forgetting to check your answers, put it in there. Now, next to that, we said, okay, how is that different from solving a linear inequality? Same thing. Simplify the left, simplify the right, isolate the variable on one side, get the constant on the other side. But in this case, you had an extra line where if you multiply or divide by a negative, you have to reverse the inequality. Now, so we started off with this list right here, and we've changed it just a little bit to get that list. And then when we went from plain old linear equations to absolute value equations, it was still simplify the left, simplify the right. But in this case, we didn't just isolate the variable. We isolated the absolute value bars and whatever was inside there. And then we solved for x, not just doing regular expected algebra like adding and subtracting, multiplying, dividing. We had to set up two solutions, two locations, as it were, to solve this. And now we're going to do absolute value inequalities. And notice it's the same thing. Simplify the left, simplify the right, isolate your absolute value entities. This part is still right here. Okay, get the constants on the other side that are outside the absolute value bars. Set up your two expected locations. But if you divide or multiply by a negative, you have to reverse the inequality. So see how these two have things in common. So there's really very little difference between the four strategies. What do you think? All right, let's try some. Now, here we go. So someone asks us to solve the absolute value of x is greater than 3. Now, I want you to kind of visualize what this is. We talked about this in the absolute value equalities. To me, these are just like little people with various names, and this person's name is x. Okay, and they are more than 3 away from 0. So if I was going to look for them, and they're more than 3 blocks, 3 units, 3 little squares away from 0, I would be looking past the positive 3, which is the greater than direction. Because all the numbers that are down there keep getting greater and greater and greater and greater. Or they would be past this 3, and this is the less than direction, because each succeeding number is less than the one before. Okay, so where would I find them? X is past negative 3, which is less than negative 3, or x is past positive 3, which is greater than 3. And I've already got it solved for x, so this would be my answer. This is inequality form. Then we can graph it, and to graph it would look like this. And so using the new kind of conventions where it's greater than would be a curve like this at 3, and a curve like this with an arrow at negative 3. And then for interval notation, we're going from negative infinity up to -3, but we're not including -3, so it's rounded. Then we're going to skip over to 3 and keep going to positive infinity. So this is your little empty section in here, in between, all right? And the U stands for union, says both are fine. I like both. Both are good. There's good answers in either one, all right? Now, since this started off with just an X and was already solved in a sense for X, then the end picture and the beginning image, so this was our image setting this up, and this is the final, they actually matched. But if it's something other than an X in there, they don't look the same. Okay? So the image that I think of, I don't know what you think of, is that this is another person that is past 4. So they're out this way. Or they could be past this -4, out this way. So remember, this is the greater than direction. And this is the less than direction. So we would have x minus 1 is less than -4, or x minus 1 is greater than 4. And we solve these. So we want to simplify the left, simplify the right. So we add 1 to both sides. Add 1 to both sides. X is greater than 5. So what this would be, if you graphed it, is -3 and 5. So it doesn't look like the original image, which was on either side of 4, because this -1 has shifted it. So we would have minus infinity to -3, union 5 to infinity. And if you want some more details about these rounded versus squares and everything, go back and see the video for just the normal linear equations. If you go back, I discuss it more fully there. All right, and we should be good. Now, in the description below are just the link to the previous and the next video, but you should be able to see in the playlist where the linear inequality one is. And don't forget that in the description there's practice problems with complete solutions for you if you want to practice this. Now, let's talk here for just a second. So do you see here where it's saying simplify the left, simplify the right, and then solve for x? We really haven't done any of these steps yet. That doesn't mean that we don't need them in the list, right? And in fact, to a certain extent, you sort of use some of those to, once you set up your two solutions, you kind of, it's like you go back up to the top and simplify the left, simplify the right. Okay. But that doesn't mean we're not going to use those. So let's try one that's a little bit more complicated. And what if we have 8 times the absolute value of 3x minus 5 plus 10 is greater than or equal to 58? All right? So we would go, oh, it's an absolute value inequality, but it's, we can do these. We simplify the left. Okay, we cannot add 10 to the inside the absolute value bars because they're bars. They keep you out. We cannot multiply by 8. We cannot subtract 5 from 3x's because they're not like. But I can work to isolate this absolute value entity. All right, and what we're going to do is, and I'm going to try to tell you these steps instead of writing them down. I've been writing them down in the previous videos, but we need to start kind of internalizing some of those steps. So I'm going to tell you the steps. So what we're going to do is first try to get this term by itself. by getting rid of the 10. And since the 10 is added, we're going to subtract. That would negate it. Okay. And what we do to the left, we have to do to the right. So we're going to subtract 10 from both sides, and we would get 48. All right. And if you need me to show the steps for a little while, I'm going to double back and show them to you. But I want you to start trying to internalize that. Right. Now, once we have got that term by itself, I need the bars, the absolute value bar entity by itself. And 8 is multiplying. So to move something or to negate something, we do the opposite of what it's doing. And the opposite of multiplying is to divide. So we're going to divide that side by 8. We have to divide the other side by 8 to be legal. So we would have 3x minus 5 is greater than or equal to 6. All right. So what we did is we divided both sides by 8. You all right? Now, this is where we kind of think of what am I actually doing? This is a person named 3x minus 5, and they are past 6 or past this negative 6 or equal to, because they might be actually standing at one of the two sixes. So this is where we set up our two cases. So 3x minus 5 is less than or equal to minus 6, or 3x minus 5 is greater than or equal to 6. So we try to simplify the left. There's nothing to do. So we would isolate our variable term, getting our numbers on the other side. We would add 5 to both sides. So you'd have 3x is less than or equal to negative 1. Over here, you would also add 5 to both sides. So 3x is greater than or equal to 11. So all we did was we added 5 to both sides. All right, on we go. Now we want to have 1x, so we're going to divide both sides by 3. So because we have 3 times, and to negate a 3 times, we divide by 3. And that's what we have. So the end result is negative 1/3 and 11/3. Looks like this. Now these are a little harder to check because there's no one specific number to verify, but you can pick one in the proper range and see if that works. So like, what's a number that's bigger than 11/3? Let's see, that's just a hair under 4, so let's try 4. So if you check x is equal to 4 to see if this makes a true statement, do not check it into here. That just says from here down your right. You check it all the way back up into the original problem, right? So does 8 times 3 times 4 minus 5 plus 10 greater than or equal to 58? That's my question. And you cannot multiply inside the absolute value bars until you actually take the absolute value. So you'd have 8, absolute value 12 minus 5. Okay, 12 minus 5 is what? 7? Oops. Absolute value of 7 is 7. And isn't 8 times 7 plus 10 bigger than 58? Yep. Okay, so that checks. And you could check another negative number, but I just wanted to show you that really quickly. Now, moving on, let's do another one. 7 minus 2 times the absolute value of 2x minus 1 less than or equal to 5. Now, simplify the left. Can you take 2 away from 7? Well, you could if it was just 7 minus 2 out in the middle of nowhere. But this particular 2 is actually multiplying the absolute value bar entity. And remember your rule of order of operations, parentheses, exponents, multiplication, division? addition and subtraction. So you can't subtract 2 before it multiplies. It has to do its multiplication job before you can subtract it. All right. But I could get rid of the 7, okay, by subtracting it from both sides. So this one's going to look kind of weird, so I'm showing you the steps. So -2, absolute value of 2x minus 1 is less than or equal to -2. Hang it in there. All right. Now we're going to divide by -2. And what is it that you have to remember to do when you multiply or divide by a negative? And you're the only one that's going to remind yourself. You have to reverse the inequality. So 2x minus 1 is greater than or equal to 1. All right. So here's my image. You don't have to show the image. I'm just showing it to you so that you have this kind of visual. I actually kind of hope it makes you smile. All right. So 2x minus 1 is less than or equal to -1. 2x minus 1 is greater than or equal to 1. So you add 1 to both sides. 2x is less than or equal to 0. 2x is greater than or equal to 2. Because we added 1 to both sides to get rid of this one, right? Now I want to know what x is. I don't want to know what 2x's are. So I divide both sides by 2. 0 over 2. 0 over anything is 0. So this is 0. Divide both sides by 2. 2 over 2 is 1. So you have from 0 to the left and from 1 to the right. So you have negative infinity to 0. Now remember, if you have an equals, you lock this off. And you can never have a squared off brace next to infinity because you never get to stop. Some students remember this because if you've got this equals underneath here, it reminds them of these flat parts of the bracket. All right. Hope that helps. Now, what about this one? 5 plus 2, absolute value of x plus 4 is greater than 3. This looks pretty good, but watch what happens. Now, we look at the left and say we can't multiply inside the absolute value bars until we know what the absolute value is. And I cannot add 2 to 5 because I would have to multiply by 2 before I can add it to anything. So I'm blocked by this multiplication. So I'm going to subtract 5 from both sides so that I can start working on isolating my absolute value entity. So when you subtract 5 from both sides, 3 minus 5 is a -2. Okay? And you could go ahead and divide both sides by 2, and you would have x plus 4 is greater than a -1. But now think about it. When you take the absolute value of a number, isn't it always going to be positive? So isn't a positive always going to be greater than a negative? So this is always true. This would be true for any value of x, because even if you put a negative in there, like the absolute value of -9 plus 4, okay, that would be the absolute value of -5. The absolute value of -5 is 5. 5 is greater than -1. So no matter what you put in here, after you take the absolute value of it, it's going to be greater than a negative. And so any number will be fine. So this is all real numbers. And the way you show all real numbers is negative infinity to infinity. All the numbers are good. Some teachers have you make this double lined big R for all real, but this is interval form. Now there's another case that looks like this. What if you're less than 2 away? All right, so when you look at where this person might be, they are less than 2 away on the right side and less than 2 away on the left side. So they're somewhere in this area. And that looks like in the linear equations when we did inequalities. We had what was considered like a compound inequality where it was an implied and as opposed to or. And they would look like, something where you'd have minus 2 to 2. And, you could have like the raised up version that looked like this, or it would look like this. And they were tied together. Remember those? So what this is this is somebody that you want within arm's reach, maybe like a loved one, a little child, or something like that. You don't want them past this two and past the other two. You want them within two. Okay? So this is somebody you want close, somebody you want within reach, right? So can you see how they're literally x minus 3 is within reach, 2 on either side of, let's say it was a toddler. Okay? You want them, sometimes you can't trust a toddler 2 feet away from you. Okay, if there's breakable stuff, not a good idea. All right, so this is somebody that you want close, right? So literally, x minus 3 is sandwiched in between these two twos, right? Here's this 2, here's this 2, and this one has to be locked in between those two. And we had this one was one of those compound inequalities where you have 3 sides now instead of just 2. So you'd start where the variable is. And to get rid of a minus 3, we do the opposite, which is to add 3. So we add 3 everywhere. So we'd have 1 is less than x is less than 5. So my beginning image and my end image are not the same. But that's because it was not just an x inside. But you're sandwiched in between. I drew it square. It should be round. Because it's less than only. So your solution is 1 to 5. All right, and you could check it, like 2's in between here, let's say. So if you checked x is 2, you would say, is the absolute value of 2 minus 3 less than 2? Okay, what's the absolute value of negative 1? It's 1. Is that less than 2? Yes, it is. All right. Let's try another one. What if you have 6 times the absolute value of 3x is less than or equal to 12? Well, we don't have any numbers to add or subtract on the outside, so we just have 6 to multiply. So the opposite of to multiply is to divide. You divide both sides by 6. 12 over 6 is 2. All right. So what I'm thinking is somebody is less than 2 away, just like what we had before, right here. So 3x is in between these 2's. And then you divide everybody by 3. So negative 2/3 is less than or equal to x is less than or equal to positive 2/3. So your interval looks like this. Hope you're doing okay. All right, let's try 2 more and we'll be done. 14 plus 2 times the absolute value of x plus 7 is less than 10. All right. You can't add 14 and 2 together. So we're going to subtract 14 from both sides. And you'd have negative 4. Now at this point, you might be going, well, wait, I can't be less than a negative. But keep in mind, you have to make that decision after you're totally isolated, because what if this had been a negative 2 right here? you would have divided both sides by -2, and x plus 7 would be less than or equal to +2, and that would work. So don't get in a hurry about saying, oh, this is one of those ones that I can just bail out on. You can't decide technically yet. Since this one's positive, you can, but let's go ahead and get into a good habit. So x plus 7 is less than -2. Can you take the absolute value of something and get a number less than a negative? Actually, can you get anything less than 0? Much less a specific negative like -2. No, that's never going to happen. This is never going to be true. So this is no solution or empty set. But be sure you completely isolate this absolute value with the variables in it before you decide. For instance, let's look at -7. -7 plus x minus 4 is less than or equal to -4. I mean, there's a lot of negatives in there, but better safe than sorry. So let's isolate this because that's what was in our list. Okay. And if it's not in your mental list, it needs to be in your physical list. Because when you add 7 to both sides, now it's less than positive. Sure, I can be a number less than 3. There's lots of positives less than 3. So x minus 4 is in between these two 3's. Now that's my visual image to start. That does not mean that's the answer, okay? So x minus 4 is visually in between these. But where is x? Okay, I know where x minus 4 is. X minus 4 is here. I want to know where x is, all right? So I add 4 to both sides, or all 3 sides. So 1 is less than or equal to x is less than or equal to 7. So while x minus 4 is between the two 3's, x is in between 1 and 7. This is where x is. This is where x minus 4 is. And so my interval notation is 1 to 7. Alrighty. Okay, hope that helps. All right, so in the next video, we're going to move on and start looking at quadratics, polynomials, and how to solve them by factoring the quadratic formula, completing the square, all sorts of neat stuff. All right, see you at the next video.